Let's do some practice with linear models. Now, I really believe in mathematics and in a lot of things. The more you do it, the easier it gets. And if you're not talking to yourself as you're working through these things, I feel like you're doing yourself a little bit of a disservice. So please, talk to yourself. It'll make things easier. Here we go. Number one, leasing a particular car costs $850 plus a monthly fee of $225. Create a model that gives the total cost for a given number of months leased. So first things first, we're going to look at the dependent variable and the independent variable. I'm talking about cost for a given number of months. Now, if you just think about this and you're like, okay, I'm going to lease a car. How much is it going to cost me? Well, it makes sense that the more months you lease it, the more it's going to cost, right? So cost depends on the number of months. Notice how there wasn't a lot of like math right there. It was just thinking through, what does this mean? The more months I have to pay on this car, the more money it's going to cost me. That's like knowledge of cars, I suppose, here. So the dependent variable is cost, right? That's the units. It represents the total cost. So that's actually, we're going to measure that in dollars. And then the independent variable is the number of months. And that is represented in months, right? Okay. So, come on, buddy. We know that this costs $850 a month plus a monthly fee, $850 plus a monthly fee of $225. So think about, when we're talking about linear models, we have a one-time thing, right? That's our y-intercept. And then we have like a recurring constant thing, which is our slope. When you think about this, it costs $850 plus a monthly fee. Which one of those is recurring and which one is just one time? Well, a monthly fee means every month I pay $225. That is a recurring item. I have to do it over and over, where this $850 is like a one-time payment, so that's a one-time. So when you're looking at what is the slope, what is the y-intercept, that's your difference, because we know the y-intercept is where we start. It's one thing. You go to lease a car, you pay up front. Here's how much you're paying to lease it. Then you pay your monthly piece. So the y-intercept is $850. So our ordered pair would be 0, $850 if we care, but B is $850. So the slope is the recurring constant change, which in this case is $225. So that means I would pay $225 for every 1 month. Is this increasing or decreasing? It's increasing because this is positive, right? It increases how much you're going to pay for this car based on how many months you're doing. So let's put these together to write our model. Don't forget, okay, so this is y equals mx plus b. So we have y equals 225x plus 850. Now that I have my model, how much will it cost to lease the car for 6 months? So y equals 225x plus 850. 6 months, that means x is 6. So y equals 225 times 6 plus 850. Order of operations says multiply first. So y equals 1350 plus 850. Final piece we add, and if you lease this car for 6 months, it's going to cost you $2,200. Great, love this for us. In the next one, you have a budget of $3,800. How many months could you lease this car? Okay, so we now know that Y is $3,800 because that's the total cost, right? That's the budget we have. Dollars is the Y value. So in our y equals 225x plus 850, I substitute that 3,800 in for y. Now we have to get x by itself. First step, subtract 850 from both sides. That leaves me with 2950 equals 225x. Divide both sides by 225. And nice and easy, x comes out to be 13.11. And if that is your answer, you are wrong. Because can you lease a car for 0.1 months? No. Remember, when you're dealing with these questions, this is like real life. You can't go into a car dealership and say, I want to lease this car for 0.1 months. They will laugh at you. Okay, you go to a rental car and then you can rent the car for, 3 days. That's fine. But when you're leasing, you do this in whole month intervals. So I can lease for 13 months. All right. So really, y'all, you all have common sense. You are all smart people. Sometimes math can be hard. I get it. But when you're doing these problems, don't let your smartness and your common sense leave you. Keep it with you, because that is really what's going to help drive you through. That's what's going to carry you through the math. All right, let's do one more here. The Happy Widget Company has a fixed cost of $1,500 each day to run their factory, and a variable cost, this means changing, of $1.25 for each widget they produce. Let's create a linear model for their daily cost. What do your X and Y represent? Anytime you are writing a linear model, I highly recommend, really exponential models too, who we kidding? Anytime you're writing a model, just take the extra 6 seconds and write down what your X and Y represent, right? We are trying to find their daily cost. We know that cost depends on what I do, right? The more things I produce, the more materials I need, the more it's going to cost. So Y is going to be the total cost. So we know that's dollars. And we're creating widgets. So X is the number of widgets. Great. Now to do our linear model, we also need a slope and a y-intercept. So we know that slope is a recurring, right? It's the constant rate of change. And we have a constant change of $1.25. Every widget is $1.25. So widget, 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 widget. Each one of these is $1.25. So there's my constant change. So my slope is $1.25. My y-intercept is a one-time thing. I have a daily fixed cost of $1,500. Right? That's to run the factory. That's to pay the employees of the day. That's to keep the lights on, the water, the whatever. That's what it costs per day. Now that I have my pieces, I can write my model. Y equals slope times X plus my y-intercept. So 1.25X plus 1,500. How much does it cost to produce 300 widgets? Well, remember that widgets represent X. So X is 300. So in my Y equals 1.25X plus 1,500, I substitute in my 300 for X. 1.25 times 300 plus 1,500. I multiply first. So Y equals 375 plus 1,500. And we can expect it to cost $1,875 to produce 300 widgets. Last question. Let's say there was a day that it cost $2,040 to run that day. How many widgets can they produce with that? Okay, well, once again, Y equals 1.25X plus 1,500. The total cost is my value for Y. So I substitute that in. 2040 equals 1.25X plus 1,500. We want to isolate the X. So the first item that I deal with is that 1,500 because it's not connected to X. So that goes away on the right side. I'm left with 1.25X. And on the left, I subtract. 2040 minus 1,500 gives me 540. To get X by itself, because the 1.25 is in front of X, that's multiplication. So I divide both sides by 1.25, and I get 432 widgets. So if my daily budget there was 2,040, I could make 432 widgets. And that is only number 2. There's one more. Goodness gracious. Okay, stick with me for holiday bonuses. They're based on years of service. Dante is a new employee and his holiday bonus was $225. Tim, who also works in Dante's department, has been with the company for 22 years and his bonus was $675. Okay, so now we are not given the absolute change. We have to find it because we know that Dante has worked 0 years but was paid $225. So we have years and we have dollars. And Tim has been with the company for 22 years and earn 675. So remember that slope is y2 minus y1 over x2 minus x1. So I'm going to take 675 minus 225 over 22 minus 0. That gives me 450 over 22, which comes out to be about 20.45. So that means the bonus increases, it's positive, so it's increasing, $20.45 each year at the company. Because remember, the denominator is years of work and the numerator is the dollar amount, right? How much your bonus increases. So there's our slope. Construct a linear model. So we know that the slope is 2045, but what's the y-intercept? Well, go back to our friend Dante, who's new. Dante was 0 to 25. He had 0 years of service, but he still got a bonus of $225. So our y-intercept is 225. So y equals 20.45x plus 225. Now let's use that model to predict the company for 13 years. So, we know that x is 13. So if I use my y equals 20.45x plus 225, you can substitute in 13, and you then multiply, right? Order of operations are important. 265.85 plus 225, and you could expect a bonus around $490.85. That reminds me of National Lampoon's Christmas Vacation in the Jelly of the Month Club. If you haven't watched that movie, you should. It's hilarious. All right, that's practicing with linear models. Thanks, y'all.